Hi everyone, welcome to the final video going through some past exam questions on buffer solutions. So this question here is starting us off with, we've got some ethanoic acid and calcium carbonate and we're mixing those together and that's going to create a buffer solution. So first of all it wants us just to write the equation for ethanoic acid and calcium carbonate. Okay, so ethanoic acid we've got CH3COOH. Calcium carbonate is CaCO3. It's going to react, it's going to make calcium ethanoate. Calcium though is group 2, isn't it? So it's going to react with 2 ethanoate ions, so we're going to have to put 2 there. So it's going to make CH3COO minus twice and a calcium ion. With these salts, you can either write it with the charges or without. It doesn't matter. But if you're going to do the charges, you have to do the negative and the positive charges. You can't like put a negative charge there and then leave that off. That's dodgy. So either put both charges or none, but it doesn't matter. So it's going to make calcium ethanoate and water and carbon dioxide. Okay, explain why a buffer solution has formed. We've seen this question before. So we have the reaction has formed the ethanoate ions. But the solution still contains the ethanoic acid. Okay, because it was important we used an excess of ethanoic acid. Okay, remember the whole point of a buffer solution is you need both of these things, and a weak acid and its conjugate base. So we've made the conjugate base, but we've still got the weak acid because an excess was used. I think we've seen that question 2 or 3 times now, just with various different, ethanoic acid or methanoic acid or butanoic acid, but it's the same type of question. Speaking of which, we've seen this question before. Explain how this buffer solution controls the pH. Okay, if you've seen this before, how many marks is this question worth? It's a 5-mark question. It's a 5-mark question every time. We're going to get 1 mark for writing out the equilibrium for the acid dissociating. And then we're going to get 2 marks for talking about what happens when you add acid and 2 marks for talking about what happens when you add alkali. So when acid is added, you can probably remember this from before, it's always the same way. Which way is the equilibrium going to shift? When acid is added, the H plus ions react with the ethanoate ions. So these 2 are reacting, so the equilibrium is going to shift to the left. Okay, this is a question that you should be looking forward to because you can get 5 marks in about 1 minute here if you're quick. And then when alkali is added, we're going to do the opposite, right? The OH minus ions from the alkali react with, they don't react with this, they react with the ethanoic acid. Or I can write ethanoic acid. I could write the formula, it doesn't matter. And the equilibrium is going to shift the opposite way. Always the same way around. Acid shifts the equilibrium to the left. Alkali shifts the equilibrium to the right. What am I writing? The equilibrium shifts. Sorry, talking and writing at the same time. Shifts to the right. Right, I've actually written something that makes sense. When acid is added, H plus ions react with this and the equilibrium shifts to the left. When alkali is added, OH minus ions react with the ethanoic acid and it shifts to the right. Yep. And remember here we could also say, instead, we could say that OH minus ions react with H plus and then more of the ethanoic acid dissociates. That would also be fine. But either way, when we add the alkali, the equilibrium shifts to the right for sure. Okay. So hopefully that's something that we're getting more confident with. Right, last bit here is we've got another calculation. So we're trying to make up a buffer solution with a pH of 5. We've got sodium ethanoate and we've got ethanoic acid. And it wants us to calculate the mass of sodium ethanoate that we need to use in order to make this buffer solution. Assume the volume of the solution remains the same. Okay, that's good, because otherwise it would be super awkward. Okay, we're doing a calculation. Where do we start? We always start with the same thing. We're going to write out Ka. We like Ka. It helps us out. Right, and then we need to have a little think here about what exactly it is we're trying to calculate here. We want to know the mass of sodium ethanoate. So how does that relate to our Ka expression? Where does our sodium ethanoate come from? Well, the ethanoate ions is this thing here, right? So this is the one that we want. Okay, we need to rearrange this expression to get the ethanoate ions. And remember, this is a buffer solution, so we can't do like H plus squared or anything. We just need to use this, but rearrange it. So we want the ethanoate ions. That's the thing we're interested in. So that is going to be, what we have to do? We have to multiply by this and then divide by the H plus. So it's going to be Ka times by the acid and then divided by the H plus. Okay, right, so then this is good. Do we actually have these numbers? We know what Ka is, that's good. Do we know the acid concentration? We do, but that was the concentration to start with. Is it going to be the concentration now? Yes, it is, because they're saying that the volume of the solution is staying the same. So if the volume hasn't changed, then there's no reason why the concentration would have changed. Okay. The key, well, having said that, how do we know that? Because there's not going to be a reaction here. When we've done buffer calculations before, we've done the table method, haven't we? Okay, we've written out the equation and we've used the ICE table. Here, we're not going to do that. Why not? Because we're adding sodium ethanoate to ethanoic acid. These two are not going to react with each other. This is a weak acid and its conjugate base. Okay, this is not partially neutralizing your acid. Okay, this is just straight up mixing the two things that you need. Okay, there is no reaction here. So there's no reaction, the number of moles aren't going to change. And if the volume isn't changing, then the concentration is not going to change either. Okay, if the moles aren't changing and the volume isn't changing, concentration is not going to change. So we could use that value for the Ka, we can use that value for the concentration, and the H plus concentration is going to come from the pH, right? So actually this is not going to be too bad. So our concentration here is going to be 1.75 times 10 to the minus 5 times by 0.2. And we're going to divide by 10 to the minus 5. Okay. Remember, if the pH is 5, to get the H plus concentration, you do 10 to the minus pH. So let's calculate that. (1.75 times 10 to the minus 5 times 0.2 divided by 10 to the power of minus 5. 0.35. Okay. And that's moles per decimeter cubed, isn't it? Right. So now let's just take stock of where we are here. So we have just worked out the concentration of ethanoate ions. We want the mass of sodium ethanoate. Let's just put something around that. Right, what are we doing? This is what we're doing. We want the mass of the sodium ethanoate. So we now need to get from this into mass. So we just want to look at units here, really. We've got moles per decimeter cubed, and we need to end up in grams, don't we? So what are we going to do? Let's multiply by the volume. Then that'll get rid of decimeters cubed, won't it? That'll give us moles. So where's the volume? The volume is 400 centimeters cubed, isn't it? Okay. So we can now multiply this by, if it's 400 centimeters cubed, it's going to be 0.4 decimeters cubed. Okay. Let's do that. That's going to give us moles, isn't it? So times 0.4 is 0.14 moles of ethanoate ions, and therefore moles of sodium ethanoate. Right, and now we need to convert from moles into mass. So now we're going to use the MR, aren't we? And we've got the formula here. So let's just work out the MR. So this is going to be 12 for the carbon plus 1 times 3 plus 12 plus 16 plus 16 plus 23. And you can look them up on the periodic table if you haven't learned them by heart. So you just use them so much that you end up learning them by accident. Right, so what we've got, 12 plus 3 plus 12 plus 16 plus 16 plus 23. Yeah, so that is 82. And now finally I can do this, 0.14 moles times 82 grams per mole. And that's going to give me my answer. 82 times 0.14. And we've got 11.48 grams. That is the mass of sodium ethanoate that we need to use. Nice.